Okay, trig fams, let's get started. This is the fourth and final review worksheet that we have on our haiku page. This one was optional. Let's take a look. More fun with trig identities. So I already worked it out for you. I'm just going to talk it through. It might go a little faster. No squares. When I have no squares, let me zoom in a little bit. Maybe that'll help too. When I have no squares, I know I'm not using my Pythagoreans, so I'm going to change everything into sines and cosines like I did here. 2 sines in the numerator, 2 in the denominator. Cosines, 1 of each, they cancel, so I get 1 is equal to 1. The second one over here, here's number 2. Number 2, I want to whittle everything down so it's equal to sine x. Okay, well that gets real small. I have 2 different terms, no squares. So you know what? Sines, cosines. So I put everything in terms of sine and cosine. And I see that I have 2 fractions with a common denominator, so why not? I couldn't help myself. I put it together. Common denominator sine x, 1 minus cosine squared. Well, that's one of your trig identities. So you should have handy. I don't have handy. Oh yeah, I do. It's underneath here. I have this. I always have this out just to help me a little bit. So where we are here. So there's my cosine squared. Here's cosine squared. I want to take this guy and make it look like the 1 minus cosine squared. So that's 1 minus cosine squared, and that's going to leave me with sine squared. So yep, I replace that with sine squared x, and I have 1 sine x in the denominator, so I reduce it and I get sine x. There it is. Let's take a look at number 3. So for number 3, oh look, that simplifies down really nicely. And I look at this denominator. Is a square. You have to try and look at your Pythagoreans if you have a square. You know what? Deja vu. We just did it, right? So this is fresh in my head. I know I can rewrite this denominator as sine squared x. And now I have the sine in the denominator, and its reciprocal is cosecant x. There it is. Number 4. So I look at this one. Oh, this one's a pretty good one. So now I want to whittle it all down. So I get cosecant squared x. Well, I look over here, and I'm multiplying 2 fractions. When you multiply fractions, you multiply the numerators, and you multiply the denominator. So I kind of already did that. Actually, I split it up for you here. And then I FOILed it out. I didn't write out the FOIL steps because it's easy enough. 1 times 1. My outers is a positive cosine x. My inners, negative cosine x. They cancel. Done. Negative times a positive, there's negative. Cosine squared, well, third time's a charm. Right now I kind of really have this one memorized, so I'm going to replace that with my sine squared x. And 1 over this, well, that's cosecant squared x. There it is. Check. Done. Next, number 5. So I look at number 5, and I'm thinking, hey, there's no squares, so you know what? Sines, cosines. Put everything in terms of sine and cosine. Well, here's the cosine. Done. Sine. Tangent is sine over cosine. I just extended my fraction so that it looks like I have 1 clear fraction here. I'm not going to bother writing the right side because I'm too lazy maybe. I don't know. But I do want to whittle tongue-tied, whittle it all down so that it's secant x. Okay. When I look at these guys, I'm adding a fraction with a non-fraction. Make them both fractions. Give them a common denominator. That means my common denominator is going to be cosine. So I have to multiply the top and bottom, right? Top and bottom by cosine x, cosine x. It's got to be the same thing on the top and the bottom. It's like multiplying by 1. So here you have your cosine squared, cosine in the denominator. Now you have your common denominator. Cosine squared and sine squared eventually becomes 1, and 1 over cosine x. Hey, that's secant x. There it is. Number 6. Ooh. I've seen this all over the and I'm write it because this one I do have memorized, right? So that's sine squared x. And now I'm thinking maybe I'll just take these and put these in terms of sines and cosines, especially when I want it to be cosine. I'm thinking, well, turning it into sines and cosines might be the right idea. So this is 1 over sine. I already see something canceling. And cotangent is cosine over sine. Oh, look, 2 sines in the denominator, 2 in the numerator. Cancel them. Cosine. Oh, there it is. Yeah, I started to write theta, so then I just wrote an x. Okay, number 7. So now I look at this guy, and I'm going to say, okay, I see a lot of squares. So yes, I am hoping that I'm going to be using, and I have to be thinking in my head of using one of the Pythagorean identities. but there's a lot happening here. And then I look here and here. And yeah, I have two terms, but I've got the same common factor. So I'm going to factor it out, GCF. So I factor out cosecant squared x, and when I factor it out, when it's the entire term, you have to have 1 as a placeholder. Minus, take this out, and there's my cosine squared x. Remember, you need that 1 because if you distribute back in, you got to get back to your original. This, again, is cosine squared x, and here's anything times its reciprocal. If you want to, you can take that, because I know sometimes we like to put everything in terms of sine and cosine. So you might want to take this and rewrite it, and then look, it cancels out. So you get 1. 1 equals 1, number 8. So I look at this guy over here, and I'm thinking, okay, Pythagorean identities? Maybe, but it's not so straightforward yet, so I am going to turn everything into sines and cosines. My paper is diagonal. Okay, there we go. Sines and cosines. So keep this guy. That's sine over cosine. Oh, look at that. That's kind of nice. So that's just my sine squared x plus sine x, and cotangent is cosine over sine. Look at that. So plus cosine squared, well, this is 1. 1 equals 1. Good times. Okay, let's see what's on the back. Number 9. Okay. Oh, see, I even wrote little notes. I got to scan this in so you guys can get a copy of this. So now, as I looked at this going on up here, I figured this might be easier for my ending step than this, because this looks a little complicated, so maybe I'll start here. So that's why I want to end up here. This is where I'm going. So I'm going to change this side. Sines, cosines, right? So that's going to be 1 over sine squared. Oh, hey, look. That's pretty nice. And now I have 1 over cosine squared, which is secant squared. And then this, I'd be silly if I didn't go ahead and look. And here it is. Tan squared theta plus 1 is my secant squared theta. So remember that I have to work the right side down so that it actually looks like this. So I do need to go that one step further to write this so that it is a duplicate of what is on the left side. Check, done, number 10. Okay, well, this kind of looks like it could be an identity in the works, but not yet, because we have 2 guys here, so we're going to turn them all into sines and cosines, so it's going to be sine squared. Oh, this is going to be cosine in the denominator. Well, that works out nicely to be tan, right? Oh, look, we just did this one. And I know that this can be rewritten as secant squared x. Oh, and that's where I was going. Secant squared x. So I work it down so the bottom, the very last thing I write in the left column is the right column. Number 11. Okay. For this guy here, I don't have my, it doesn't say cosine squared x like all of the other guys. Like, it doesn't look like this, right? So this says tan squared x. This is the entire thing squared, which means write it twice and FOIL it all out. So I did. So I'm writing it twice here, and I'm going to multiply my firsts, sine theta, my outers, sine times cosine, and my inners, cosine times sine. I'm going to say first, those guys are the same. One and another one of these, that gives me 2. 2 sine x, cosine x. If you feel better writing it out, go for it. I'm not. Positive times a positive, cosine times cosine is cosine squared. Now, I'm kind of like, wait a minute, see this? There it is. Feeling pretty good about that because I have the right side. I just have extra stuff here to get rid of. But look, sine squared x plus cosine squared x, that's equal to 1. And then I have this minus 1. So plus 1 minus 1, well, that's 0. So 2 sine x cosine x, and that's what's equal to the right side. Check, and I'm moving on over here on the right. Very last one, number 12. Okay. Oh, I kind of came all the way down here. Well, maybe I'll make this a little bit bigger so we can see it all. No, I didn't mean bigger. I meant smaller, like that. Okay. So, oh, I need a common denominator. Okay, this is where I'm going. This is probably the easier side to turn this into that. So I need my common denominator. in order to get a common denominator when you have two completely different denominators, you have to multiply them by each other. Okay, so that's kind of like having 1/3 plus 1/4, right? What's your common denominator here? Well, it's going to be 12ths, because 3 and 4 don't have anything common. There's no smaller denominator. The least common denominator is the product of these. So you multiply this side times 4, this side times 3, right? Times each other. Well, we're going to do that here also. So your least common denominator, or just the common denominator, is going to be the product of these two. Well, there it is. So I kind of rewrote my left side, and I rewrote the right side. I ran out of space, so I didn't even bother with my equals. But my left side, see this? This is my original, right? And then I multiplied the numerator and denominator by that new piece in the denominator. Minus, because there's my minus, 1 over this times, and this is my new piece in the denominator, top and bottom. Okay, so let's do this. Simplify the left side, and let's see, I FOILed this out, right? So 1 times 1, my outers and my inners cancel, and then I'm going to get negative cosine squared x, fine. Same thing on this side, so I just rewrote it. Okay, here's the thing. See that minus 1? I had to distribute it, the whole thing. So negative times a positive, there's my negative. I made this a plus so I could do that. So that's negative 1, and eventually you're going to have plus 1 and minus 1, cancels out. And then I have a negative times a negative, oh, that's positive, cosine x. So cosine x plus cosine, hey, that's 2 cosine x. And my denominator is sine squared x. And I'm loving this, but they want us to do something really weird and wonky. So now we can't change the right side to be sines and cosines. Wish we could, but we can't. We're supposed to make sure that the left side eventually looks like this. That's the whole process. So, okay, fine. So now what I have to do is work with my sines and cosines. So I kind of split them up. And I was like, okay, wait a minute. Cosecant, well, that's 1 over sine. So I kind of took one of my sines and I pulled it off to the side. And that left me with a cosine over a sine. And you know what? That's cotangent. So that kind of worked out nicely. So I rewrote this as 2 cosecant x, cotangent x. And that is where we were going over here. So check, and we are done.